Hi everyone, my name is Neha, and in this video, we'll be learning about the basics of combinatorics. Let's get started. Over here, we see two formulas. One is NCR and the other is NPR. NCR is equal to n factorial divided by r factorial times n minus r. Let me put the r over there, factorial. NPR is equal to n factorial divided by n minus r factorial. Now, you must be wondering, what do both of these formulas mean? And what does this exclamation mark over here mean? Well, this exclamation mark is called a factorial. The basic form of a factorial is n factorial is equal to n times n minus 1 all the way to 1. For example, 4 factorial is equal to 4 times 3 times 2 times 1, or 24. 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. Therefore, 4 factorial is equal to 24. Now, NCR, this formula over here, NCR, is used when you have to select r objects out of a total of n objects. This is used when you select. And we use this formula, NPR, when we have to arrange r objects out of a total of n objects, n total items. So, this is used when you arrange. Now that we know both of these two important formulas in combinatorics, let's learn two other important principles in combinatorics and another concept in combinatorics called set theory, which we will learn in the following videos that come on this topic. These two principles are called the addition principle and the multiplication principle. These two principles are used when you count in combinatorics or when you're counting in combinatorics. Counting is an important concept in combinatorics, which isn't like counting on your fingers, 1, 2, 3, 4, 5, and so on. It's a more advanced type of counting, but it's easy to learn. Our first principle is the addition principle. Let's see what it has to say about the addition principle. Suppose E1, E2, E3, all the way to ER are events that are pairwise disjoint. Then the number of ways for at least one of them to occur is N1 plus N2 all the way to Nk, where Ni is the number of ways for Ei to occur. Now, what does this mean? It means when you have these many events from E1 to ER that are pairwise disjoint. So pairwise disjoint is a phrase in combinatorics that means not comparable. For example, if you have a group of objects or numbers or etc. and objects, then those group of objects would not be comparable, meaning that you wouldn't be able to add or subtract them or do anything with them together. Then the number of ways for at least one of them to occur is N1 plus N2 plus Nk. So what this means is that this is the number of ways for at least one of these events to occur, where this value over here is the number of ways for another event to occur, where this I over here, if you notice carefully, is equal to the I in this event. Now, let's take an example in addition principle. Let's say that you have 3 pencils, 1, 2, 3, and 3 erasers. I'm going to keep the erasers as squares and the pencils as circles. 3 pencils and 3 erasers. Now, we can use addition principle over here when we have a question like, let's say we have to choose 1 pencil or 1 eraser out of this group of objects. Then, how many ways can we choose them? Well, we can choose either this, or this, or this, or this, or this, or this, or 3 plus 3, which is equal to 6 ways. This is an example of the addition principle. Now, one thing to keep in mind, you'll know when you have to use the addition principle or the multiplication principle when you have the keyword or, you'll use the addition principle, and when you have the keyword and, you'll use the multiplication principle. Now, let's move on to the multiplication principle. Suppose that an event E can be composed into R-ordered events, E1, E2, E3, all the way to ER, and there are ni ways for E1 to occur. Then, E can occur in N1, N2, N1 times N2 times N3, all the way to NR ways. Now, what does this mean? This means that there's an event E that is broken down into these events, E1, E2, E3, all the way to ER events. So this is, in total, R-ordered events. And there are these many ways for this first broken down event to happen or to occur. Then this bigger event E can occur in these many ways. Let's take an example of the multiplication principle. Suppose we have one city A that is joined to another city B by 3 roads, 1, 2, and 3. Then the city B is joined to another city called C with another 3 roads, 4, 5, and 6. Now, my question is, in how many ways can you travel from A to C? Well, let's count them. You can first travel from A to B using road 1, and then you can travel from B to C using road 4. So 1 through 4. Then you can go from A to B using road 1, and then B to C using road 5. So in total we have 1 to 4, then we have road 1 to 5, then we have roads 1 through 6. Now we already used road 1, so I'm going to check mark this. Now let's use road 2. From A to B using road 2, you can use road 2 from A to B, and then you can use road 4 to get from B to C. So use road 2, then road 4. You can use road 2 again, and then use root 5 to get from B to C. Using root 2 again from A to B, you can use root 6 from B to C. Now I'm going to check mark root 2, and let's use root 3, which is our last root left from A to B. So we can use root 3 from A to B, then root 4 from B to C, so 3 to 4, then we can use root 3, and then we can use root 5 from 3 to 5, and then use root 3, and then root 6, so it's 3 to 6. Now, if you count the total number of ways, I'm going to check mark this too. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. But there's a shorter way to do this using the multiplication principle, which is basically 3 times 3, which is equal to 9 ways. The reason I did 3 times 3 is because we have 3 routes from A to B, and then we have 3 routes from B to C. If you take a moment to think about this, then it'll make sense. That's why you do 3 times 3 to get 9 ways. Either way, your answer should be 9 ways. Now, let's move on and do one final problem. So, our problem is there are 8 racers who run a 100-meter relay race. Each one of them get different times. How many ways can the racers get a time? So, in this problem, we'll be using a concept in combinatorics called permutations. So, permutations and a concept that we learned earlier in this video called factorials. So, I'm just going to put 8 dashes here for the 8 races. 1, 2, 3, 4, 5, 6, 7, 8. Now, there would be 8 times because 8 number of times because there are 8 racers in total. So, the first racer could take 8 times. The second racer you might be thinking would take 8 times, but that racer wouldn't take 8 times because the first spot over here already took 1 time. So it's 8 minus 1, which is 7. Also, let me make this clear in the problem. There would be no repetitions of times. Now, since this 7th spot over here took 1 time, we'll do the next spot can take 6 times. Now, this spot already took 1 time, so it'll be 5 times. The next spot will be 4, the next one will be 3, then 2, then 1. So, your answer will be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or 8 factorial. So you can calculate this amount using a calculator, or you can do it right now. Well, thanks for watching this video, and I hope you liked it. See you next time. Bye!